Assalamualaikum warahmatullahi wabarakatuh. So today we would like to present about vector function and space curve. Vector functions are mathematical functions that describe vector using a parameter, usually represented by t. They help us study the position and motion of object in two-dimensional and three-dimensional space. A vector function is written as rt equal to xt, yt, and zt, where each component represents movement along the x, y, and z axis. Next, the space curve is the path traced by a vector function as the parameter change. In simple words, it shows how an object moves through space over time. These concepts are very important in calculus, physics, engineering, and robotics because they help us analyze the motion, velocity, and acceleration. Now, let's move to the first question. Given the vector function is rt equal to t squared minus 1, 2t plus 3, and t squared plus t, we can identify that x is equal to t squared minus 1, y equal to 2t plus 3, and z equal to t squared plus t. First, we must express the parameter t in terms of y, from the equation y equal to 2t plus 3. Then we get t equal to y minus 3 over 2. Next, we substitute this value of t into the equation for x and z. And for x, we obtain that x equal to in bracket y minus 3 over 2 squared minus 1. And then we simplify this equation, then we get 4 in bracket x plus 1 is equal to in bracket y minus 3 squared. For z, we substitute the same value of t. Z is equal to in bracket y minus 3 over 2 squared plus y minus 3 over 2. After we simplify the equation, we get the 4z is equal to in bracket y minus 3 squared plus 2 in bracket y minus 3. Therefore, the Cartesian equation of the curve are 4 in bracket x plus 1 is equal to y minus 3 squared, and 4z equal to in bracket y minus 3 squared plus 2 in bracket y minus 3.
So, I want to discuss about medium question. So, we look at question 2. The question given is determine the point curve when t is equal to 1 and find the Cartesian equation. So the given equation is r in the bracket of t is equal to in the bracket of t squared plus 1, comma 3t minus 2 and 2t squared minus t, and the question is 5 mark. So we look at the solutions. We need to make the three equation of x, y, and z. We will look at the equation the matrix given, which is x is equal to t squared plus 1, y is equal to 3t minus 2, z is equal to 2t squared minus t. So, since the t is given, t is equal to 1, we need to find the point curve. We just substitute the value of 1 in t, replace with 1. So we get r in the bracket of 1 is equal to 1 square plus 1, 3 in the bracket of 1 minus 2, and 2 in the bracket of 1 square minus 1, and we get 2, 1, 1, the point curve. So we need to find the t as a subject. It doesn't matter if we take from x or z, but we will take y because it was the simple one. T doesn't have any square. And we get t is equal to y plus 2 over 3. So we will substitute t, value t that we get in the equation that we find above. So we get x is equal to y plus 2 over 3 square plus 1. The equation is t square, so we must make it in the bracket of square. So we get 9 in the bracket x minus 1 equal to y plus 2 square. So for the y, we look at for the z, we look at the equation is t 2t squared. So we just replace t with the t value in the equation. So z is equal to 2y plus 2 over 3 square minus y plus 2 over 3. So the question is 5 mark. Will move in space such that its position vector is given by r in the bracket of t in the bracket of 4 cos t, 4 sin t, 8 sin 2t minus 4 cos t. So the question asks us to eliminate the parameter of t to obtain the Cartesian equation for the curve. So for the solution is, we need to make a equation in the x squared plus y squared equal to 16 in the bracket of 1 equation. So we look at the x squared. X squared is given, x squared is equal to 16 cos square t. So we look at the x given in the equation above. So x is 4 cos t, while y is 4 sin t. So y square, we will get y square is equal to 16 square t. So we just make it like x squared plus y squared is equal to 16. We just solve it and we get the last equation. So move x squared plus y squared equal to 16. We get same as we just did. So we can make t as subject. So we will get sin t is equal to 1 over 4. And cos t we will get x over 4. So just substitute the value of t in the z equation, which is 8 sin 2t minus 4 cos t. So just substitute it, we will get z is equal to 8 in the bracket y squared over 16 minus 4 in the bracket x over 4. So we will get, and we will simplify it, and we get z is equal to 1 over y squared minus x, and the last equation is in the form of x and z. We get 1 over 2y squared. So that's all from me about the medium equation. Thank you.
So now let's proceed to the next question, which is heart level question. Let's begin with our question. The question 4. A particle moves along the line segment joining the points A 4, negative 2, negative 1 and B negative 2, 6 and 9. Then find the vector equation and parametric equation of the line segment from A to B. Hence, determine the Cartesian equation of the line, the midpoint of the line segment, and the distance between the 2 points. Now, let's look at the keywords in the question. First one, we must need to find the vector equation, the parametric equation, Cartesian equation, midline of the segment, and lastly, the distance. Let's begin with finding the vector equation. First, we must need to know the R0 and R1. To find vector equation, the formula is RT equals to, in the bracket, 1 minus t R0 plus t R1. From here, we know that R0, we can get it from the coordinate of point A. And then R1, we can get it from the coordinate of point B. Just substitute the coordinate in the formula. And then we will get RT equals to 4 minus 6t. And then a negative 2 plus 8t. And lastly 1 plus 8t. Don't forget to write the domain of the parameter. Next, we have already got our vector equation. Let's move to the next one, which is parametric equation. To find parametric equation is just simple as x, y, z. Why do I say x, y, z? Because to find parametric equation, we can refer to vector equation. RT is equal to coordinate x, coordinate y, and coordinate z as I labeled here. So we can get our parametric equation, which is x equal to 4 minus 60, y equals to negative 2 plus 80, and z equals to 1 plus 80. Next, we will move to the Cartesian equation. For Cartesian equation, there are two steps for us to know. The first step is make the t as the subject, or we can say make the parameter as the subject. And then, we must need to combine all of it in one equation. To further understand what I said, let's look at the question. We have found our parametric equation, right? Which is x equals to 4 minus 60, y equals to negative 2 plus t, z equals to 1 plus 80. We must need to bring the t and make it as the subject. For example, x equals to 4 minus 60. We will simplify and make the t as subject, and we can get the t is equal to 4 minus x over 6. Same goes to y and z. Once we're done with the t, we combine it all in one equation. As I stated here, we already get our Cartesian equation. Next, we must find the midpoint of the line segment. Okay. To find the midpoint of the line segment, we must need to know the formula. So what is the formula to find the midpoint? To find midpoint, the formula is in coordinate x2 minus x1 over 2, y2 minus y1 over 2, z2 minus z1 over 2. x2, y2, z2 we can get from coordinate b, while x1, y1 and z1 we can get from coordinate point A. So then, once we substitute all the value in the formula, we get that the midpoint of the coordinate between the line segment is 1, 2, and 5. Lastly, we were asked to find the distance. To find the distance, the formula is square root x2 minus x1 in the bracket square plus y2 minus y1 in the bracket square plus z2 minus z1 in the bracket square. Then we substitute all the value from point A and point B into the formula, and we get that the distance of the line segment is square root 164. We can also simplify it and write it as 2 square root 42. We have completed our question. That's all from me. Thank you.